Welcome to the project demonstration of underground cable fault identification along with data log into the Thingspeak cloud. So here we are going to send the location where the short circuit got occurred. So that will be uploaded to the Thingspeak through this ESP8266 module. So this is the previous data which we have got uploaded into that. So initially there is no fault 00. Whenever the fault is occurred, it will show us the status along with the time and date. So that we can see that R2Y faulted 30 kilometers and the time and date will be uploaded. So same thing for the B and Y and B and R. So like this. And the next, coming to the components wise, so we are going to provide the 230 volts input to the system, and that transformer will step down the 230 volts AC to 12 volts of AC that was input to this regulated power supply board, and which will take the 12 volts AC and provide as a 5 volts constant DC. So here the stages are rectifier, for smoothing purpose filter, and 705 regulator. So after this, this will get the 5 volts constant power supply that was input to this current measuring voltage measuring circuits along with to the microcontroller motherboard parallelly to the buzzer and ESP8266 module and 16:2 LCD screen, and 230 volts input parallelly given to this bulb through this electromagnetic relay which will operate through the PIC microcontroller. So coming to this section of this PCB, so whenever the short circuit occurred between the R and Y phases, then based on the length of the wire, so in real time we are going to measuring the length of the wire along with the resistance. As we know that resistance is proportional to the length of the wire. So whenever the length of the wire increases, then the resistance increases. Then whenever the short circuit occurred, there will be a chance of voltage drop. So the particular drop voltage will be measured by the PIC microcontroller. So here we are manually making the fault. So based on the fault position, microcontroller will get the voltage drop, and the voltage drop will be parallelly converted into the distance, and that will be displayed on our screen, as well as uploading that same data to the Thingspeak with the help of this ESP8266 module. So next, before switching on this kit, we need to enable the hotspot in your phone. So enable the hotspot with the name of project 5037 and the password should be 129. After enabling the hotspot and data, log into the Thingspeak and stay on the page, and now then only you can switch on the kit mode. Right. So once we switch on the kit, there will be a welcome message on the LCD screen, and this Wi-Fi module will be connected to our mobile phone. So you can see that on the status. So right, the connected devices. So now wait for the new data to be uploaded. So here data uploading speed is, it will be uploaded for every 10 to 15 seconds of duration of as right. So we got the new data. So if you want to erase the old data, before erasing that, if you want to download that data, so just go to data import export, download the data and open that. So there we can see the data in Excel sheet. So it will it consists of date and time along with number of entries and so-called data. This RY, YB and BR. So now after that, download was completed. Now if you want to erase that, go to channel settings. Here only do clear channel. So confirm. Once a clear channel done, then go to again private view. So private view to see the data, channel settings to clear the channel, data import and export to download the data. So now the old data got to be erased and we'll get the new data. Right. Okay. So now if you manually create any fault, so this is a 10 kilometers, 20 kilometers, 30 kilometers for all the three phases. Whenever the fault occurred, it will display the R2Y fault at 10 kilometers. So wait the data to be uploaded into this. So till that, just the buzzer. Right. So right, the data got uploaded into that R and Y fault. So we created the R and Y fault here, and this one is for the Y and B, and this one is B to R. So once it was rectified, then automatically the bulb got switched on, and the same data will be uploaded here. So let me show you that. So if you want to see the so-called fault data in the Thingspeak, you need to wait till the 15 seconds of the duration, because the data will be uploaded into Thingspeak website for the duration of 15 seconds maximum. So now coming to this, it's R2Y 20 kilometers, and the next R2Y 30 kilometers, same 10. Right, let me place this as a fault Y and B now. So Y and B as of now till is 0. So once 10 to 15 seconds time completed, then we'll get the data. So coming to the connections, meanwhile I'll explain you that. So these checking circuitry connections were made at A0, A1, A2 pins, as we are going to measuring the analog voltage. So that's why we need to connect them at A0, A1, A2 pins only. And the next ESP8266 module is connected at the B0, B1, and LCD at B2 to B7, and buzzer at the connection was C4 pin. And the next relay is connected at the C3 pin. So as we see that the relay is operated 5 volts directly, it will get the trigger from the motherboard, and once when we are switching on and off this relay, there may be a chance of it will generate the back EMF. So for that purpose we have connected a reverse bias diode, so which will act as a freewheeling diode. So this will neutralize the ripples directly which were generated from this relay. Right, so we got the data here. So when it is back to normal again,